Properties of exponents. If I have something to a power over something to another power, you subtract the powers, don't you? And so this would become, this is going to look a little weird, but just bear with me. I'm going to have x squared minus 8, x minus 1 on top. On the bottom, I still have this 2, and I still have that root. What I still had left to resolve was what this was, right? And I'll just do that real quick over here. That's x minus 4 to the half over x minus 4 to the 2, which is x minus 4 to the, you subtract. 1/2 take away 2, you get negative 3/2, don't you? Yes. But because it's negative, I'm going to drop it back down to the bottom and make it positive. So this becomes x minus 4 to the 3/2. That's more like what you would see in the back of the book. Okay? So what I would say is when you're doing your homework, I believe in the homework solution videos for this, I usually take you to the raw derivative only. I don't think I take you the whole way, but I challenge you, I think in the homework videos, to try and match your answers to the back of the book. Because this is all algebra. From here down, it's algebra. And so you need to get better with that algebra because later on we're going to need to be able to do that algebra. So start practicing now. I told you the test, 8 out of 10 points is you getting the calculus done right. The other 2 out of 10 is you doing the algebra after it correctly. So you can't get an A if you can't do the algebra, but you can still pass. Yeah? Ow, what the hell? All right. Let's see. Yes?
Do you know why beavers are so good at math?
Why beavers are good at math. They keep chipping away at it?
It's because they understand logs.
They understand logs. Okay. I took a shot at it. Okay, how about this one? Secant of the square root of x to the third minus 2x squared plus 1. I'm not taking this out of the book. I looked at the book, looked at the problems, and said, yeah, let me do that. And let's see, Michael Sanchez? I think I called him. Heidi? I called you. And Edward, I called you, right? Tatum, I called you. No? I did, right? Emmanuel? I called you? No? I did?
I don't know how many people are just nodding their head.
Yeah, I trust your integrity. Chris? I call you? I didn't last time, did I? Okay. All right, so Chris, the first thing is you have to know what rules you're going to use, right? I mean, you have to know. So now we have chain. Pardon?
We're doing a lockdown drill.
Oh yeah, there's a lockdown drill at 2 o'clock. Yeah, I think everyone's about to get a text or something. Okay, so we are officially locked down. Nobody leave. Okay?
So does that mean you're going to barricade the door?
We could practice barricading the door if you want.
Yeah, sure, why not?
Back up. Oh, lights off. Oh, I'm supposed to turn off the lights.
Yeah, let's take some tables and barricade the door.
See, I thought we had an active shooter right there. I was going to see who was gonna defend us.
But can we actually practice putting a table on the door?
I was not instructed to do so, and I think that would be, yeah, no.
So that is composition?
Pardon?
That is composition?
Yeah, see, I can get in a way that would turn off the lights, but I can keep the projector on. So,
I think it's better this way.
yeah. Wait, but who was up? Who was up? You almost got off, Chris. Almost got off there. Almost. Okay, so you have to recognize what rule you have to use. So what do you see, Chris? Because when it comes down to it, it's all about what you see. Composition? Okay, so if you see composition, that means you need to see an outer function. So what would your outer function be? Secant, okay? And then do you have another function inside of that? Okay, and then do you have another function inside of that? All that polynomial stuff, right? So this is 3 chains to this composition. You'll agree? We have an outer, a middle, and an inner. All right, so now, Chris, I'll stick with you here because I believe in you. Chris, what's secant of this? Is nasty, right? What's secant of this nasty thing, Chris? So if you don't know, you're going to have to go to your formulas because I didn't put it up there. So does anyone have the formula? I know what it is, but I want someone to read it off their thing. Yes? Okay, so the derivative of secant x is secant x tangent x, right? That's what it is on your formula sheet. I said, don't worry about memorizing these now, but by the time you're in Cal 2, you should probably have this memorized, all right? So Chris, be careful. Let's read this. If you're trying to take the derivative of secant of this rag, the derivative will be secant of what? Okay, so secant of what? Of the rag. So secant of the rag, I'm just going to put rag here for a second. And then what? Tangent of the rag, right? Understand? So the rag, what was the rag covering up? Square root of x cubed minus 2x squared plus 1, and then that same thing here, square root of x cubed minus 2x squared plus 1. What did that text say? Did anyone see?
The drill.
That's all it said?
I'm not trying to lose 10% on my next test, so.
Oh. All right. Chris, are we done? Is this the answer? No, it's not, but don't worry, Chris, you're done. Trey, how's it going? I see you back there. Trey, you get the next part. So what should I do now, Trey? That's right. So I'm done with secant, right? So I'm going to take derivative of the square root. I'll do the stapler again. So Trey, what's the derivative of the square root of a stapler? 1 over 2 times square root of the stapler. Look, if it seems like, I don't mean to be like insulting your intelligence by using staplers and rags, but if it makes sense, like let's just do it until we don't need to do it anymore. You know what I'm saying? Good? Is that it, Trey? Are we done with the middle? Yes, we're done, right? So we are done with the square root part. And now, Trey, I think you can do the rest because you got to go inside now, right? Take derivative. What do you got there?
2x squared or times
3x squared. Yeah, times 3x squared
minus 4x.
minus 4x. And Trey, would that be correct on a test? Parentheses. There you go. Derivative of 1 is 0. That's why that's not up there, right? That's it. Now this, I don't think we can clean this up much. Can I cancel one of these roots? No, these are trapped inside trig functions, right? So you can't. The most you could do here is put like this, this, and this all in a numerator, and then over this is a denominator, and then pretty much just be done at that point. All right, good. So, true story. I was in graduate school. I was sitting in a class called Functional Analysis, which was probably the hardest class I ever took. And the fire alarm went off in the building, right? And so people like outside of our door started like scrambling down the hallways and stuff like that. And my professor, Dr. Williams, as we started to like get our stuff together and stuff, and he said, no, you know, sit down, shut the door. He said something to the effect of like, we were studying Banach spaces, and he's like, Banach spaces is too important for us to be disturbed today. And so it actually was not a drill. It wasn't a fire though. Someone had like pulled the alarm or something. It was, I don't know, but it wasn't a drill, and we didn't go anywhere. And
Man, it's funny, like someone from
Yeah.
that class went after
Yeah.
the Usher, pulled the fire alarm,
Yeah.
and they came back in
and it didn't work. Too bad. Yeah. Yeah. I think nowadays that'd be a lawsuit right there. Okay. More? More? I think it's time for you to do some of these on your own. I think well, you know what? Just a couple more. Just a couple more to see some problems that seem trivial but aren't. How about this one? What's sine of the derivative of sine of 4x? So you have composition here, don't you? The outer function is sine, the inner function is 4x. So when you take the derivative, you first, I'm going to take the derivative of sine of my hand. Derivative of sine of my hand? Cosine of my hand. My hand was 4x. Then times, now the derivative of what's inside. What's the derivative of 4x? 4, right? So this is just 4 cosine 4x. Make sense? What about this? Y equals sine of negative 7x. See if you can do that one in your head. So it should be what? Negative 7 cosine of negative 7x. So you say, what's derivative of sine of my hand? Cosine of my hand, right? Times derivative of what's inside. What's derivative of what's inside? Negative 7. I slide it out front. Yeah? Okay, how about this? What's the derivative of sine of 4x minus 3? 4 cosine of 4x minus 3. Okay? Derivative of sine of my hand is cosine of my hand, right? Times derivative of what's inside. Derivative of that is 4. So that 4 comes out here, but I slapped it out front. You get this?
You can turn the light back on.
I can? How do you know? Did they say it's over?
No, I don't know.
MVC drill, all clear. Oh, it's an all clear message. Back to life. Sorry. All right, so how about this, everyone? What would the derivative of sine of ax plus b turn out to be? So what I'm saying is that x is a variable here. A and b are constants. So I'm not giving you what a and b are. What we're actually going to get here is like a general formula. So the derivative of this should be a times cosine of ax plus b. See, because derivative of sine of my hand is cosine of my hand, but then derivative of that is just a, because a is a constant. And b is a constant. Well, a is attached to the x. That's why the derivative of ax is a. But b by itself derivative is 0. So you get that a to pop out. This is actually a good thing to know. What about this one? What if I change it up a little bit? What if I say y is cosine of ax plus b?
Cosine is negative sign.
Yeah, so we would get a negative sign of ax plus b, right? Then the derivative of what's inside would be a, wouldn't it? So you would have that negative in front of the a, and then sine of ax plus b. So just do this on your own. You know, cover it up. Do derivative of cosine of something is negative sine of it, and then times the derivative of what's inside, and then when you move that a to the front, you'll have a negative a. You could do this for all the trig functions: tangent, secant, cosecant, cotangent. And the thing that makes this like this a pop out right here is the fact that what's in here is linear. And anytime you take the derivative of a linear expression, you get the constant that was in front of x, right? If this is linear, the derivative of that is a. Now, if this turned out to be like quadratic, it wouldn't be the same. But it's linear, so that's what happens. All right, let's do a couple. We're going to make this a quiz. You are allowed to work together, all right? But that means I don't want you just copying your neighbor. I want you to work together or work on your own. Yes?
Just a quick question. I might be the only one with confusion. I was going to ask, how can you, I guess, concretely tell the difference between when you need to use composition and product? Because I think in one or two of the problems I couldn't identify, like when to use.
Well, we had one problem that was like this, and I don't remember if this was exactly it, but I think this was. We had that one, and then we had another one that was like, I don't know what this was, but like those two. These two right here. When you look at this, do you see that product? Right? Do you see an outer function? Do you see like a last thing happening? Well, the squared is happening just on this piece though. It's not happening on the x. You see? So there's no like last thing that occurs. It's two things that happen kind of simultaneously. So they're separated by the multiplication. So like you could figure out what this is, figure out what that is, and then multiply them. Here, if you were to do this, you would have to figure out all this junk first, and then at the end, you would have to take sine of that, right? So this is composition, this is product, but that product has a little composition inside of it.
Okay, so okay, that's all.
That this right here by itself is composition. Yeah. Does that help clarify it? Okay. Here we go. So I'm going to turn all the lights on, and I'm going to disconnect this. Turn this off. You will have the rest of class to work on this. Well, we only have 20 minutes. What the heck? Oh, there it is. Okay, here it comes. I want you to find the derivatives of all of these, all right? So y equals x squared secant x. Y equals x cubed plus x over x squared plus 1. Y equals cosecant of the square root of x. Y equals sine cubed of x squared plus 9. Y equals x cubed times cosine of 1 over x squared. And the last one, y equals x over x cubed plus 1 all to the 8th power.
And then this is using all the rules or just changing?
Everything. Everything's at play here.
Is it one paper for the whole group?
No, everyone does their own. Everyone does their own work and turns in their own paper, and don't do it on the back of the notes you were just writing because you're tearing it out and giving it to me, and you may never get it back. No, you'll get it back. Okay, so we'll number these, all right? There you go. Just calculate the raw derivatives. Don't worry about algebraically simplifying them right now. Just try and get the derivative done, all right? Y'all hear me? Just raw derivatives.